You're listening to Darkcity Radio Live. Tune in at www.darkcityradio.com. You can find us by searching Darkcity Radio on Facebook or Twitter.
Good evening, Dark City. Welcome to the Permaculture Show. This week, I'm very pleased to welcome the very knowledgeable Brigit Strawbridge. Hi, Brigit.
Hello, Nairis.
Hi. Oh, I was considering, Bridget, if you don't mind, I think you should be renamed the Bee Whisperer. What do you think?
Oh, I like that.
Okay, that's it then. I'll just say, before we get into it, my Skype can be a bit unpredictable and I do jump in and out. So I'm a bit elusive like that.
Okay.
That happens. There's other lovely people who jump in, and obviously you'll be in your flow anyway, so it's cool.
Okay.
So I don't know, so did you want to start with the sort of pesticide issue, Bridget, or did you want to talk about types of bees?
Well, okay, I think it's probably a good idea to start with an overview, so that people, just to put it all into context, and we've got about 40-50 minutes, haven't we? We're doing questions as well at the end.
Well, I think so. Yeah. I mean, we'll kind of go as it flows, sort of thing.
Okay.
But it's always nice for everyone to jump in, and
All right.
yeah.
So in that case, if I kind of treat it as if I'm doing a talk, so that's probably the easiest way to do it. And I really would like to focus a little bit later on the pesticides issue, the neonicotinoids, because that's current and it's incredibly important and topical at the moment and very, very confusing. So if I start just by what is a bee? Sounds like a very simple question, but so many people think if I talk about bees, they say, oh yeah, I know someone who's beekeeper. I know something about honeybees. And of course, there are so many more bees in the world than just the honeybees. So in the entire world, there are about 20,000 different species of bee. In this country, in the UK, we've got about 260 species of bee. So one of those is a honeybee. About 24 of them are bumblebees, and the rest are solitary bees. So these are people who keep honeybees would dispute this, but I'm going to refer to our other bees as wild bees and honeybees as honeybees, just because it helps, it makes more sense. Honeybees are, of course, wild as well. So the different bees have different roles as pollinators. The honeybees, for instance, are very, very good on agricultural crops, and this is kind of the way things have gone, with the great big fields of monocrops that we have growing across the countryside. And in America, this is excessive and requires excessive amounts of honeybees. So that's why you get the crazy situation in the United States with the almond crop. Hundreds of thousands of acres of almonds and millions of hives of bees that are transported across the states to pollinate them. So it's not quite that bad in this country with honeybees, but they are, as a rule, and I'm generalising here, they are good for some of our agricultural crops. Honeybees have short tongues. Bees have either short, medium, or long tongues, and depending on the length of their tongue, there are certain crops that some bees can pollinate and other bees can't pollinate. So all of the legumes, for instance, your peas and your beans, they need a bee with a long tongue. So that rules out the honeybee. So this is starting to build up a picture of, the different bees for different crops. And then the bumblebee has an incredibly clever thing that it does that no other bee, other than a few of the solitary bee species, can do. And this is something, it's called buzz pollination or sonication. And what the bumblebee does, if you imagine a tomato plant, a tomato flower, it's got the yellow flower, and it doesn't want to give up its pollen. It's tight closed, and the stamen inside are hidden and protected. And this is very, very difficult for bees to get to unless they're bumblebees. And what the bumblebee does is it flies along and it kind of wraps its body around the yellow tomato flower, and then it disconnects its flight muscles and starts to vibrate the flight muscles at about 400 hertz. So this is like a tuning fork. This is nature's tuning fork. And it suddenly, so everything's vibrating, and suddenly the tomato plant will open, the flower will open, and the pollen will crash out onto the underside of the bumblebee, which will then go onto another flower. And this is how plants like tomatoes and aubergine and pepper and things like that are all pollinated. So that makes the bumblebee very important. Then you've got solitary bees, and solitary bees are, again, massively important as pollinators for lots of reasons, but mainly because they're messy. So when a solitary bee goes along to a flower, particularly say a fruit, the flower of some soft fruit or apple or pear trees, they immerse themselves in the pollen. They kind of have a pollen bath. Honeybees are a little bit more kind of fastidious, and they sort of nip in and the other thing is honeybee is after the nectar mostly, but solitary bees feed their young on pollen. So they dive in and take the pollen, and they get it all over their bodies. They don't put it in neat little pouches on their hind legs like honeybees and bumblebees do. And so, for example, there's a very common and quite a well-known solitary bee in this country called the red mason, Osmia rufa. And the red mason is capable of doing the same amount of work as 120 honeybees in the apple orchards. So that's pretty important. And that's just 3 different ways, so honeybees, agricultural crops, also they're out in masses of numbers at this time of year when the bumblebees and the solitary bees are just small in numbers. And then you've got the bumblebees that do the buzz pollination, and the solitary bees that are messy pollinators and great for apple orchards and so on and so forth. So together, if you look at this holistically, we need all of these bees. And this is just bees. We also have that there are. So I've already mentioned there are 20,000 species of bee on the planet. There are actually 200,000 different species of pollinating animal. And they would include bats and birds and butterflies, moths, beetles, flies, hoverflies, and a few small mammals. So between them, we need this is from a permaculture point of view. We need diversity. Biodiversity is so important, and of course, to sustain all this huge array of pollinators, we need to keep diversity of flowering plants as well. And this is when one starts to go into decline, then it's kind of obvious that the other will too. And I think the technical name for this is an extinction vortex. And gradually, if we don't take more care and provide for the needs of bees, for instance, then bees in particular are keystone species, then whole ecosystems will begin to collapse around us. And this is just dire. So that hopefully covers the importance of bees, not just within a permaculture system, because I know that we're going to talk about permaculture, bees and permaculture, but worldwide, just to sustain all of the ecosystems on this planet. So what I want to do now is just see if I can talk to you a little bit about the other differences between honeybees and bumblebees and solitary bees. So we know that, or most people already know, that honeybees are they're kept in hives. They're kept by beekeepers, and they're kept in colonies, and their numbers could reach up to 50,000 in a single hive. Doesn't have to be in a hive. There are wild colonies of honeybees too. So the honeybees, 50,000 bees, one queen, a dozen or so drones, depends on what time of type of the cycle it is, and the rest are all female workers. The bumblebee colonies, and again, bumblebees are also social bees. So the bumblebee colonies would be, they go from between about 50 to 200 in number at the height of the season. And another difference between honeybee colonies and bumblebee colonies is that honeybee colonies overwinter. So the entire hive overwinters. They stay in the hive for most of the winter, but they do overwinter as live bees. Bumblebees, on the other hand, bumblebees, only a newly mated, fertilized queen will overwinter. So with bumblebees, the fertilized queen will go into hibernation it could be as early as July or August, but more normally in sort of September, maybe October time. And she overwinters beneath the ground. She digs herself deep down into the ground, and she has kind of like an antifreeze substance in her blood that stops her from freezing if the ground gets too cold. And so she overwinters, and about now, so about April, March, April, if the weather's a little bit better than this, she will emerge from under the ground, and she will basically spend a few weeks prospecting for a nesting site, and her chosen nesting site would be an abandoned rodent's nest, would be what she would be looking for, but they are few and far between now. So she's basically looking for somewhere where she can make a nest, mostly beneath the ground, but some of them in tusky grass as well. So once she has found a suitable nesting site, she will clean it out and prepare it and waterproof it, and then she will collect pollen and nectar. And what she does here is amazing. She will make a tiny little honey pot, a little bit like the Winnie the Pooh shaped honey pots, and she fills that with nectar. And this nectar is so that she can have something to feed, so that she can stay in the nest and sit on the eggs that she's going to lay. So she's got this little honey pot with nectar, and next thing she does after she's got the nectar is she will put together a little pea-sized ball of pollen and nectar and a little bit of wax, and then she lays about half a dozen eggs into this, and then she broods them just like a bird. So she sits on this tiny little pea-sized ball with the eggs in it, and she keeps her body temperature. This is something bumblebees can do. They're very effective at bringing their body temperature up to about 30 degrees. Keeps the eggs warm. The eggs will hatch out after a few days, and they go through the larval stage, and then they pupate, and then they will emerge after about a month as fully adult bees. So there's no such thing as a baby bee. And once they've emerged, so these are all females at this stage, and they will become the workers for that colony. So the queen at this stage will not leave the nest again. So this is, our queen will stay now, and she will keep providing more and more broods, and the amounts of bumblebee female workers will increase and increase until at some stage in the middle of the summer, the queen will start to produce they're called reproductives, which are males and then daughter queens. So the males will leave the nest, and the males are never allowed back in again because they don't do any work. So the males are out there basically sunbathing and foraging for nectar. You can actually tell, you can have a pretty good go at telling the difference between a male or a female, because if you see a bumblebee and it's hanging out on a flower, not doing much work, not in much of a hurry, and it has no pollen on its hind legs, so its hind legs would be quite hairy and quite thin, whereas the female bumblebee's legs will be a bit shinier at the top and a bit smoother, a bit thicker and able to carry the pollen. And the other way that you can tell a male bumblebee from a female bumblebee is that the male bumblebees have facial hair and they have little kind of yellow moustaches. So, I'm generalising, but that's basically a good way to tell the difference. So male bees are out there and they're establishing territories. The female bees, the new daughter queen bumblebees, will then leave the nest. And there are a number of different ways that they will find each other and mate, which probably haven't got time to go into. But once they have mated, the mated queen will then stock up on pollen and nectar, and she will then go into hibernation. And that is basically the full bumblebee life cycle. What will happen then with the old queen and the rest of the workers is they will die off, and that brings us all the way to winter again. So that's the life cycle of a bumblebee. Solitary bees, and as I say, there are about 250 odd different species of solitary bee in the United Kingdom, and they have a very short life, a solitary bee out of the nest, that is. So if we start again with April, and I'll use the red mason bee as an example. So the red mason bee, which is the bee, lots of people who are listening have probably heard of bee hotels, so kind of, or bee houses. They're stacks of bamboo canes chopped up and put inside a wooden box or something, or lots of holes drilled into wood. And basically, the red mason bee will search for a hole, a cavity like that. And what she will do, she'll be doing this in around April, early May, and she will go to the back of the hole, or the back of the piece of bamboo, and she will provision it with a little bit of pollen and a little bit of nectar, and then she'll lay an egg. Then she'll block that up with some mud, and then she will do the same thing all over again. There's a bit of pollen, a bit of nectar, and an egg and some mud, and she'll carry on until she has filled the entire cavity or the tube, then lots of soil, lots of mud at the very, very front to protect it from predators. And she'll maybe fill 4 or 5 tubes with eggs like this. And that will take her 3-4 weeks, and then she will die. The eggs will develop inside the tubes, much in the same way as the bumblebees did. So they'll hatch out, they will become sort of larvae, and then they will become pupa, and by the end of the year they will be fully developed adult bees, but they'll stay in their cocoons until the following April. So that's about now, and what happens now is that these bees will be waking up, the sun comes out, that is, and the bee at the very, very back wakes up first. So what it does is it nibbles its way out of its cocoon, and if the bee in front of it is still asleep, it'll nibble its way into that bee's cocoon and then nibble its bottom until that bee wakes up, and so on and so forth until the front bee wakes up. Front bees are always males, and they will emerge. The females will emerge, they will mate, and that whole life cycle will start all over again. So three different life cycles there. So much more that I could say. I could talk, as anyone who's heard me talk would know. I could talk. I could talk for a whole day.
That's fine.
About one bumblebee or one solitary bee species, but I won't. So what I'd like to do now is come on to decline, bee decline. So bee decline is affecting all of these bees, all pollinators, but we're just talking about bees today. Now, bee decline is down to so many different reasons for bee decline. Climate change is obviously massive, and you can see at the moment lots of these solitary bees will be freezing, literally freezing in their cavities at the moment. Some of them may not emerge. The bumblebees that came out too early will have frozen to death. So climate change and the mess that's going on there is a problem. There's also a lot of disease. That there are lots of different fungal diseases and bacterial and viral diseases that are killing bees. Mobile phones could be impacting on bees, but the two big ones that I want to talk about are habitat loss and pesticides. Habitat loss is it's tangible. We can see it. We have lost, since the end of the Second World War, 98% of our wildflower and grasslands. So our meadows, they're gone. They've just gone. Now, this has happened for a number of reasons. If we go back to the 40s or just post-war, there was the mechanisation and industrialisation of agriculture. So this is when we used to have small farms with crop rotations that were managed in such a way that the way that the farmer managed the crops was also absolutely perfect for bees and for all wildlife, for all other small farmland birds and amphibians and reptiles and so on. So that started to impact. That was followed in the 60s by pesticides, introduction of pesticides, and pesticides like DDT. So people will have come across Rachel Carson's book, Silent Spring. And this was back in the 60s. Rachel Carson warned us, Silent Spring, that we were heading for a world where there would be silence if we didn't stop using pesticides. And we still are using pesticides, obviously, and I'm going to come to that again in a moment. But following on from the 60s, we get to the 70s and the 80s, and we join the common market. And farmers then started to get grants, enormous, whacking great big grants and subsidies to grub out their hedgerows and their small woodlands, the spinneys, to fill in their ponds, to plant wheat right up to the very, very corners of their fields. And this was probably this had the biggest impact of all. This was devastating. And ironically, of course, farmers are now given subsidies to plant wildflower margins to try and help pollinators. But an awful lot of these bees, and in particular, this has impacted on bumblebees. And it's impacted on bumblebees because, if you remember, I said bees have different length tongues, or proboscises. The bumblebees' tongues, lots of them have long tongues, and lots of the wild flowers were suitable for long-tongued bees. So now that those wild flowers are in decline, so are the bees that relied on them. So that's habitat loss. But then what I want to focus on now is pesticides. So until recently, until 20 odd years ago, pesticides were used reactively. So that means if a crop was plagued by a pest, the pesticide would be sprayed, the insecticide would be sprayed on it as a reaction to the pest being there. Now, about 20 years ago, things changed, and a new group of pesticides was invented by a company called Bayer Crop Science. And this pesticide is there's a group of them actually, and the group of pesticides are called neonicotinoids, or some people pronounce them neonicotinoids. They are nicotine based. So a neonicotinoid pesticide is systemic. Systemic means that instead of the pesticide being sprayed onto the leaves or the flowers or whatever of a plant, it coats the seed. So seeds are coated, or sometimes soil is treated with the systemic pesticide. And once the seed has been coated with a neonicotinoid pesticide, the whole plant takes that pesticide up through its vascular system, So it goes into the roots and up through the stem into the leaves and into the flowers, and crucially into the pollen and the nectar. So the entire plant is now toxic, can't be washed off, and what these pesticides do is that they are neurotoxins, so which means they're nerve poisons, and the whole purpose is to impair the nervous system of their target insects. So their target insects are creatures like all invertebrates, like vine weevils or aphids, or the Colorado potato beetle, or the pollen beetle. So these are their target insects, but it just is blindingly obvious that they are also going to affect other invertebrates, including bees, and also, incidentally, lots of the aquatic invertebrates. Just before I come on to the effects that they have upon bees, I just wanted to mention that these pesticides are persistent in the soil. Now that means they stay in the soil, and they stay in the soil for between 2 to 4 years, and some of them for even longer. There's one of them that's capable of staying in the soil for up to 19 years. So it's horrendous. They're also water soluble. They get into the groundwater and the surface water, and then into the streams and waterways. So they're pretty nasty pesticides. One of them, I'm going to talk about 3 of them. There are many different pesticides in this group of neonicotinoids, all manufactured by Bayer, who invented them, but also now by a company called Syngenta, and also another company called BASF. Now, I'm going to talk about imidacloprid, clothianidin, and thiamethoxam. Imidacloprid is there's been research that's been done in Holland a few years ago that proves that imidacloprid is over 7,000 times more toxic to bees than DDT. So this is a toxic pesticide. Now, Bayer and Syngenta and the agrochemical industry insist that these pesticides do not harm bees. They say that this is because bees ingest them in what they call sublethal quantities. So a sublethal quantity, this is if you imagine a human being going and taking one dose of something or a swig of something that on its own isn't going to do that much harm. But then if you go back again and again and again, hundreds of times a day, obviously whatever this is going to build up in your system. So the bees are going back again and again and again to the pollen and the nectar. And what would not have harmed them in one dose gradually begins to cause harm. And it does it in a number of ways. It does it so that chronically it's making the bee, it's impairing the bee's immune system at the very least. It's causing damage to its nervous system because that's what it's meant to do. And over a period of time, what's happening with bees, and there have been so many papers on this, so much research has been done all over the world in the last, these pesticides have been on the market for 19 years. So what's happening is the bees' nervous system is being impaired. So in the case of honeybees, very often they are not able to find their way back to the hive. So this could be one of the main causes for colony collapse disorder. They're also not able to groom themselves properly. The grooming issue is of great importance because honeybees are separately being plagued by a mite called the varroa mite. Now, a honeybee that's got a good immune system and is able to groom itself has got at least a fighting chance of grooming off the varroa mite. If it can't groom, it's got no chance. So this is causing a problem. The other problem, and this is where the whole thing was first spotted, is that when these seeds are planted, if they're planted in the summer, when it's very, very hot and dry, then a dust is kicked up. And although when a bee takes pollen and nectar in sublethal doses, it doesn't kill it outright. If it is in the field at the same time as that dust is thrown up, it will die outright immediately. That's lethal to it. And back in the early 90s in France, and I've looked this up on the internet, I've seen videos and photographs of the French sunflower seeds back in 1994, and it's absolutely horrendous. You see bees and people walking through the fields and they're ankle deep in dead bees. This is why the French, you see, right back then, the French beekeepers kicked up a stink about this, and France, it took them a few years, but they went ahead and they banned the use of imidacloprid on the sunflower crops. And in fact, over the next few years, so during the late 90s and during the early to mid 2000s, France, Italy, Slovenia and Germany have all banned certain neonicotinoids on certain flowering crops at certain times of the year. So their governments have listened to the beekeepers and paid attention to the scientific evidence that says that these substances are killing bees. Now, winding back in time, it's a good time to say now that when these pesticides were first brought to the market, the way that our pesticides regulation system works is such that the people that do the tests on the pesticides are the companies that manufacture them. So Bayer, when they brought them to the table, said, yeah, we've done tests and they're fine, they don't kill bees. At that time, there was no way of being able to test for sublethal effects or for chronic effects. So they were passed and registered without ever having been tested on a whole life cycle of a bee or for the sublethal test. So wind forward now to 2013. There's so much public opinion against these pesticides. There are charities like BugLife. BugLife has led the campaign since 2009 to try and get the UK government to ban neonicotinoids over here. We have them on about 3 million to 4 million acres of land in the UK, by the way. It's about a third of all our arable land is treated with neonicotinoids. So BugLife produced a report that and also went to the government, went to DEFRA with all of this evidence to say, look, these are proving lethal to bees, they need to be banned. The government, the UK government, will not ban. They will not countenance a ban. Syngenta basically have a lot of power over here as lobbyists. They have a lot of money. The campaigners don't. The charities don't. The NFU would rather not see these substances banned. They put out all sorts of scaremongering propaganda to say that should we lose neonicotinoids, our crops will fail and our farmers will revert to more damaging insecticides and pesticides like the organophosphates. Now, so I'm sorry to be jumping around a lot here, but it's important to say at this stage that in Italy, when these were banned, so that they were banned back in, I think it's 2008 in Italy, and surveys have proved that following the ban, they didn't lose any yields. There was no increase in economic damage due to pests, and in the meantime, Italian beekeepers reported a decrease in their honeybee colony losses, and the same happened in France. So, basically what I'm saying is our crops will not fail en masse if we withdraw neonicotinoids from the market. So whilst Bug Life and the Soil Association, Pesticides Action Network and Friends of the Earth, and now also the RSPB and all the wildlife trusts and the Women's Institute are all calling for these pesticides to be banned or at least partially banned. But our Minister for the Environment is Owen Paterson. And, this is a guy who is pro-nuclear, pro-GM, pro-fox hunting, pro-badger cull, pro-neonicotinoids. So the UK government are fighting tooth and nail to keep these pesticides in use in the UK. Meanwhile, in Europe, and this is why I really don't know much about politics, but I'm kind of thinking, thank goodness, for the first time I have a view on this, and my view is, thank goodness we are in the EU, the European Union, because the European Food Safety Authority, EFSA, became so concerned about the amount of reports about these substances being toxic that they basically decided to go back to the drawing board, reassess them from scratch. Reassess them. They brought on board, I don't know, 30, 40 scientists from all of the European member states, and they re-examined about 60-odd scientific papers, and they concluded that these pesticides are not safe, and they suggested that they be partially banned. So the European Commission proposed, they put forward a proposal in January to say that imidacloprid, clothianidin and thiamethoxam be partially banned for 2 years, starting from this July. So that they're a bit more specific than that. They said that they mustn't be sown during the dry summer months, that they mustn't be used on flowering crops that are attractive to bees, and they mustn't be used on sprays that are sold in garden centres where everyday people can go along and use them in vast quantities. So this went to the European member states for a vote, and there are 27 European member states, and when they vote, they have a strange way of voting. Some member states have more votes than others. So I think the UK and Germany and France have I can't remember whether it's 27 or 29 votes each. Poland have quite a lot of votes, but it goes all the way down. The smaller the country, the fewer the votes. So some countries only have about 3 votes. So basically, these countries all came together on the 15th of March, and they voted on the European Commission's proposal for a partial ban on neonicotinoids. 13 of the member states supported the proposal, including Spain and Poland and the Netherlands and France. 9 voted against the proposal, that they were all smaller countries with fewer votes, included Ireland, by the way. And 5 member states abstained, and they included Germany and the UK. So when you first look at that, you'd think, oh, great, at least they only abstained. I'm thinking UK here, at least we only abstained. That's not so bad, but it is, because the way that this vote works is that there needs to be, I forget the correct political term, but a weighted majority. And so that's 13 for, 9 against, and 5 abstains. But you add the 9 and the 5 together, and that makes 14. And that's the way this vote went. So 14 did not support it, and 13 supported it. So it hasn't happened. The ban that we desperately hope might happen has not happened. The UK, their reason for not for abstaining, they say, is that DEFRA were in the process of conducting their own research. They all of this incredible scientific peer-reviewed research from all over the world is not good enough for DEFRA. So they went away and they have conducted their own. They wanted to do field trials, and to go out to the field and do trials that would be of greater significance than all of these previous trials. Now, they did their trials on bumblebees, and incredibly, the results came out, I think, in February. And their control group of bumblebees actually came back to the colonies, in some cases, with even larger traces of neonicotinoids than the other two groups, because they were near fields of oilseed or sugar beet, or I don't know what, sunflowers, flax, crops that have been treated with neonicotinoids. So I heard an interview with Dave Goulson, who is he's a scientist, he's an expert in all things bumblebee at Stirling University, and he was saying that he was on Farming Today a couple of mornings ago on Radio 4, and he was saying that this research that DEFRA have done really would not stand up in any scientific journal. It hasn't been peer reviewed. Some of the data has been left out. So this is what our governments are basing their decision upon, and it for me it just really does beg a belief. So that's basically where we are now with the neonicotinoid situation. Is that there are at least 13 countries in Europe who are calling for a ban. We need to up that. This is going to be voted on again in May. And there is very clear evidence that public pressure and signing petitions, and so many people think, what's the point in signing an online petition? That there is every point. And also, even more importantly, writing to your MP and your MEP and asking them to please put pressure on Owen Paterson and on DEFRA to reassess their stance and to ban these substances. So for people who are listening who are thinking, I really want to write to my MP or my MEP, but I don't know what to write, go to the Bug Life website, and if you put in Google, just put in neonicotinoids minister letter, Bug Life, you will come to a page where they not only give you the wording, but even better, when you get a standard crazy letter back from your politician saying, yeah, we love bees, we're doing everything we can, Bug Life will then give you a follow-up letter to send back. So basically, write to your MPs and your MEPs, because the amount of letters they're getting has been proven. Friends of the Earth have seen evidence of this. It is making a difference. It's starting to sway them. And also sign all of those online petitions. Sign the Avaz petition. The Avaz petition so far has 2.5 million signatures on it. Now, this is being reported in the national press. This is having impact. There is starting to be like a whole sea change in public opinion, and like with the Women's Institute coming on board. So basically, keep pressurising. Don't feel that because the pressure didn't have an impact with the vote that took place on the 15th of March, that it won't have an impact in May. And if you have for anyone who's listening, if you have Facebook friends or internet friends in Europe, please get them to do the same, because this is a whole European, everyone in Europe needs to unite to put pressure on their governments to vote to support this proposed ban in May. I'm just looking at the time. We've got 10 minutes. So what I'll do is I'll wind up there. I think I've probably explained as much as I can on that. friend me on Facebook as well. I'm Brigit Strawbridge on Facebook, and I've also got a Facebook page that I called British Bees, and I do update. I put every time I get new information. Sometimes I'm prolific poster, sometimes 4, 5, 6 times a day. Something new is happening. It's like in the next week I'll be telling people about that there's some organisations in the Netherlands are being taken to court by Bayer. There's a big court case coming up about Bayer not releasing the information that they have tucked away about these pesticides. So lots of ongoing information. Leaving pesticides for a second, coming back to the habitat lossing, the other thing you can do apart from lobbying the pesticides issue is to plant more flowers. Make them as diverse as possible in flower shape. So, you need tubes, bells, open flat flowers, traditional cottage garden flowers like foxglove. Bees like blue. If in doubt, plant something blue, because bees see in blue. They don't see in infrared, they see in ultraviolet. Plant a succession of flowers to flower the whole year round, so that you don't have bees starving in March or June. You need constant foraging for them. Leave your dandelions. Never pull a dandelion out. I mean, dandelions are fantastic anyway. Their tap roots are brilliant at breaking up soil. They're there for a reason. I know, obviously, they're going to compete with your vegetables sometimes, but let them flower if you can, because they are massively useful to bees. Have a look, website-wise, have a look at a website called Foxleas, Foxleas. You put Foxleas Pollinator Garden. It's absolutely amazing. And they will give you a huge amount of advice. Or basically go down to your garden centre and have a look and see which flowers are attracting bees in your local area. Look in your next door neighbour's garden. So don't just go and look at a list of plants on the internet. Have a look and see what's attracting bees in your local area. And leave your garden messy. Nettles as well. Yeah, nettles are incredible. And also the white dead nettles. Oh, nettles are also really good for ladybirds. But white dead nettles, fantastic for certain species of bumblebee. All of the Mediterranean herbs. Try to leave habitat as well. Leave rotten logs and things like brambles and all the plants that have hollow tubes. Lots of the solitary bees nest in tubes, and if you have lawns, let them grow. Allow them to grow, so you get things like clovers and vetches and self-heal and dandelions again. And obviously, as I'm saying, you can eat dandelions and you can make coffee from dandelions. Dandelions only even heal so much with dandelions, turning into a dandelion show. So Lisa, I think that's me done, because we're coming up to, I think it's 5:02 and I've talked solidly. I'm sorry. So yeah, there you go, bees.
Brigit, that was wonderful what you've just done.
Oh, hi, Bob.
It's really good to hear you, and the fact that a lot of the plants that most people consider not worthy are really beneficial to bees.
Oh my goodness, yes.
All the herbs, a lot of the weeds, actually, we can eat dandelions and nettles, and they're really good for us.
I know, it's crazy. It's you think that all of this, whatever we have in abundance, for some reason or the other, people seem to see as a weed. It's just a crazy situation.
It is. Everything has a purpose. You just need to find what it is.
And also the other thing, just one last thing I forgot to mention. People focus so often on flowers that they forget trees as well. Although trees don't need bees for pollination, bees need trees. Oh, I wrote a blog post there, on bees need trees in my blog. But basically things like willow, the salix, at this time of year, there is nothing that is more important to bees than being able to come out of hibernation and forage on willow. And then, hedgerow shrubs as well. It's terribly important. So it's not just flowers. And God, if anyone knows anyone in any local council, so they can get them to stop planting all of those, begonias and busy lizzies and plants like that, and maybe plant some Mediterranean herbs or something that actually has got some pollen and nectar in it, then that's another thing. It's good on wildlife corridors. But very last thing, okay, if you provide within a permaculture design or any design for the needs of bees, you will in turn be providing for the needs for everything else, all other flora and fauna. So that's it in a nutshell.
I think a good thing to add to that is that a quarter of every mouthful of food that you eat has to do with bees.
It is. I think it's actually a little bit less than that, but it is. It's between a third and a quarter, and that includes for people who eat meat. That includes the meat on your plate, because cows and sheep in particular feed on things like alfalfa and clover, which is pollinated solely by bees. So yeah, it's from a human point of view. Can't do without them. A third is more than, between a quarter and a third. But it is about I'm rubbish at maths, always was. Yeah, it's about a third, Bob. Even more.
And you know how precious they are. If you held one in your hand, they just absolutely are amazing. And they're not dangerous. They won't sting you or anything. It's beautiful.
They're not aggressive. Bees are not naturally aggressive creatures, and they're just absolutely incredible. And the more time you spend outside watching bees, the more you fall in love with them, and the more you sort of get back into nature and into the wonderment that is the natural world. It's fantastic. They're just amazing. Just totally in love with them. Apart from anything else, I'm far more worried about bee decline for the sake of the bees, actually, than I am for the sake of the human race.
Yeah, also, Brigid, please come on again, because there's loads more we can talk about. So
I'd love to, yeah. No, sorry.
Well, that's right, you just need to come back.
I'll come back to your question.
Can I just say a huge thank you to Brigid? That was absolutely brilliant. That was so enlightening. And we would love you to come back on, please. And we're very sorry for the production issues at the beginning of the show. And now episode for 2. Who's next, babe?
Bosto is next.
Bosto is next.
And thank you very much.
Oh, is it not Miles?
For listening
Bosto with
Miles.
It's Miles.
It's Miles. Miles, because Bosto's looking after her.
Bye, everyone. Thank you. Thanks, Nairi.
Bye. Thank you, guys.
Bye.
Bye.
Bye.